Okay, so in our previous segment, we learned what fluid resistance was. So the thing that's going to slow down the flow of a fluid. How is that going to be related to the pressure, which is going to be the pusher of the fluid? So we have this equation that says that the pressure, the pusher, is going to be equal to the volume flow rate and then multiplied by the resistance. So this is the fluid resistance. This is going to be the actual flow of the fluid, and then this is what's causing it to happen in the first place. Notice how similar this is to electricity. So when it was electricity, the pusher, instead of being pressure, we said that it was the voltage. Instead of the volume flow rate, this was the electric current, the flow of the electricity. And then instead of fluid resistance, then this was electrical resistance. So I just wanted you to see that in physics, a lot of these concepts can be written using the same kind of terminology. So here's a sample question. If the fluid resistance decreased while the pressure on the fluid remained constant, what would happen to the volume flow rate? So this thing over here is going to get smaller, but this thing over here is going to stay the same. So what's going to happen to this thing? It's got to get bigger. So 4 is equal to 1 times 4, but it's also equal to 4 times 1. So if one of the letters gets smaller, the other letter has to get bigger in order to compensate. Okay, let's take a break. When we come back, let's talk about Archimedes' principle.